Hi there, I'm Rebecca Weaver. We're going to be looking at applications of the natural logarithmic function to economics, section 5.3 today. We're going to need the definition of relative rate of change. So for a given function f of t, the relative rate of change of f of t per unit change of t is defined to be the rate of change, which is f prime of t, over the actual value f of t. The percentage rate of change is the relative rate of change of f of t expressed as a percentage. By definition, the quantity on either side of the equation, if we take the derivative of the natural log of f of t, we get f prime of t over f of t. It's often called the relative rate of change of f of t per unit change of t. Isn't that cool? A way of comparing rates of change of two different situations. So let's look at an example. Suppose we're looking at the percentage rate of change, and we have the price of wheat per bushel at time t in months, and it's approximated by f of t equals 4 plus 0.001 t plus 0.01 e to the minus t. What is the percentage rate of change of f of t at t equals 0, t equal 1, and t equal 2? Now, these are time in months, so it'd be 0 months, 1 month, 2 month. Since we have f prime of t equal to 0.001 minus 0.01 e to the minus t, just taking the derivative of f of t, we see that f prime of 0 divided by f of 0 and plugging those values in, we get about minus 0.22%. Let's do the same thing for f prime of 1 over f of 1, punching in those numbers and punching them in my calculator, I get negative 0.65%. We're looking at f prime of 2 over f of 2. Punching in those numbers, we'll get negative 0.0087%. So, at t equals 0 months, the price of wheat per bushel contracts at a relative rate of 0.22% per month. 1 month later, the price of wheat per bushel is still contracting, but more so at a relative rate of 0.65%. 1 month after that, at t equal 2, the price of wheat per bushel is contracting, but much less so at a relative rate of 0.0087%. So the elasticity of demand, capital E of P, at price P for demand function Q equal F of P is defined to be capital E of P equals negative P times F prime of P over F of P. Notice how that looks like the rate of change, doesn't it? The change in revenue is the opposite direction of the change in price when demand is elastic, and in the same direction when demand is inelastic. So let's look at an example of elasticity of demand. A subway charges 65 cents per person and has 10,000 riders each day. The demand function for the subway is Q equals 2,000 times the square root of 90 minus P. Is the demand elastic or inelastic at P equals 65? Should the price of a ride be raised or lowered in order to increase the amount of money taken in by the subway? Well, we're first going to have to determine E of P. So we have our Q, which is F of P, and then we have our Q prime, just taking that derivative, and then taking that derivative we get negative 1,000 over the square root of 90 minus P. So then we're going to say that E of P is negative P times that F prime of P over F of P. So just substituting in P's for those and simplifying, we get that E of P equals P over the quantity 180 minus 2P. Now we're going to determine what value of P for E of P equal to 1. So just set that puppy equal to 1 and then solve for P. We'll multiply both sides by the 180 minus 2P, collect my P's, and we get P equals 60. So P equals 60 is the point at which the E of P changes from elastic to inelastic, or vice versa. So through simple inspection, which we could have done in the first place, we can determine whether the value of E of P is greater than 1 elastic or less than 1 inelastic at P equals 65. We could have just plugged that in. And we would have found that if we'd have plugged in the 65, we'd have got E of 65 is 1.3. That's greater than 1. So the demand is elastic at P equal to 65. Since the demand is elastic when P equals 65, this means that for revenue to increase, the price should decrease. Elastic and inelastic demand. We say that demand is elastic at price P naught if E of P naught is greater than 1, and inelastic if E of P naught is less than 1. And here's our elasticity rule. When demand is elastic, that means E of P is greater than 1, the change in revenue is in the opposite direction of the change in price. And when demand is inelastic, E of P is less than 1, the change in revenue is in the same direction of the change in price. All right, so if you have any question when you're doing your homework, be sure and email me, and have a wonderful day.